Okay. Good morning everybody. Today we are going to learn about the image formation in case of a convex mirror, and the previous video, in the video number 3, we have learnt about the image formation in a concave mirror, all the 6 cases. Now today we are going to learn about image formation in a convex mirror. We know very well what is convex mirror. Convex mirror generally is the mirror in which the light reflection takes place on the outer surface. Okay, for example, this is a mirror. Now see, I said you, if the silver paint is done, some kind of paint, if not silver, generally people say it as silver paint, but okay, some other chemical is also applied. Okay, so now if the light reflection takes place on the outer surface, means like this, okay, then what will happen, the image, okay, forms on the other side of object, means behind the mirror it will form, right? Now what we will do, we will take so this is convex mirror. So to get the image, what we will do, we will take like this. So see, at any other position, so when you are keeping the object at any other position, okay, other than infinity, no need to mention the position, simply you can draw. In the case of infinity, no need even to draw the object also. That case we will see afterwards, but now see here, object generally I will call it as AB, and arrow mark, the light ray is coming like this parallel to principal axis and going like this is pole of the mirror. Now this light ray will appear for a person who is seeing from here, it will appear as if it is coming from F. And another light ray, for example, if this is C, okay, the center of curvature, another light ray will appear to come from C like this, okay, like this it will fall and it will go back. So now here the image will be formed. That is the reason in vehicles you can see big vehicles like buses, lorries, etc., though they are bigger in size, they appear very small here. Okay, so like that. So this is A dash B dash is the image formation. So what you have to write, you can write some points here. What are the points? See, the points are, what is the position of the image? So position of image, you have to say the image is formed at behind the mirror, okay, on the other side of object. Okay, so image is formed, okay, image is formed behind the mirror on the other side of object, you can say, or on the other side of object also. Okay, and nature of image, you can say nature of image, what you will say, see, the light rays are appear to come from, means if a person is seeing from here, if your eye is here, or if a person is seeing from here, if your eye is here, you are the driver. For example, generally this is used in a rear view mirror in automobiles, etc., generally. So now if the person eye is here, for him it will appear as if the light rays are coming from here. So light rays are not really coming, they are appear to come from, so the light rays are not really going there, means not traveling there. So that is the reason we say it as virtual and direct image. Already I said you, whenever you are using only one mirror or one lens, etc., virtual will be always at and real will be always inverted. Now size of the image, it is anyhow, you can see object size is bigger than that. Even practically you can see the vehicles will be bigger in size, but in the image in the mirror they appear smaller in size. So definitely what you can say it as diminished. So in this way, see, for every, if an exam, if anything will be asked like this, you have to write these 3 points. Okay, point number 1, point number 2, and point number 3 compulsory. Okay, now coming to the next, see, when the object is at infinity, actually this second case is not given in this Telangana syllabus, etc. Okay, but generally you should know, see, for conceptual understanding I am saying. See, now what you do here, when the object at infinity, you write, when the object is at infinity, how the image will be formed, means generally it is point sized, or you can say it as highly diminished. For example, see, generally light rays, when they are coming parallel to the principal axis, what you do, the light rays will go like this, but the light rays will appear to come from F. So here you would say point size diminished object, here the image will be formed. Image won't appear, but generally you would say. So here no need to draw the okay, object, means somewhere here the object might be there. So somewhere here the object might be there, like AB here, like that. okay, but we don't generally mention generally. So that is the reason what I am saying is we no need to draw object in the exams for infinity case. Generally you have to take infinity means some very far distance, okay, compared to the focal length of the mirror, okay. And in this case you can write the nature and all. Position of the mirror is at f, position of image will be at f, okay, at f. And nature you can say, what is the nature? Nature of image will be of course virtual and direct. Why? Because the light rays are appear to come from or appear to meet. And size of image will be highly diminished, you would say, or you can say point sized, okay. Now we will go next topic. See, regarding the sign convention, next topic we will go. This is done. So this is nothing but rear view mirror. So in exams if they ask why it is used as a rear view mirror, means you have to say why a convex mirror is used as a rear view mirror, means you have to say it as because it forms a virtual erect image, okay, because it forms a virtual erect image, okay. And what you have to say the other reason, because it gives a larger field of view. Larger is also called as wider field of view, wider field of view. So these two reasons you have to write, okay. So compulsory this erect word should be seen in the answer script, and larger field of view, so this should be seen, okay, then only they will give full marks, otherwise no, okay. Now coming to the next, we will go with sign convention. Now what is sign convention is generally in Telangana syllabus etc., I mean state syllabus, the object will be taken always right side in textbooks etc. But in some books like CBSE or some other what you call publications, private publications, I don't want to say the names, but those they are giving object on the left side, okay. When you take left side, generally why they are taking is because they will apply their Cartesian coordinate system, okay, coordinate system they will apply. And generally what will happen, if you are taking the object on the right side, generally based on sign convention, u value you will get negative because there is a point, okay. Distance is measured in the opposite to the direction of the light ray, or should be taken negative. So based on that point, light ray will be coming from left to from right to left like this. But when you take a Cartesian coordinate system like this, for example you are taking a concave mirror here, for example, okay, now you are taking a concave mirror. So you so light rays coming from right to left, so you will be taking the distance from for example somewhere here object is there, so you will be taking distance from left to right, you will measure the object distance. So in that way also directly you will get u as negative value, u is negative. But okay, so why most of the people will take object on the left side other syllabus is because if you take the object on the left side, for example say here this is a concave mirror, okay, see here this is concave. So when you keep concave this like this, then the silver point will be this side and object will be kept this side. So here you are measuring minus x axis, means negative x axis, this is positive x. So directly since you are measuring negative axis, you can say it as u is negative. Or otherwise here the light ray is coming from left to right, okay, and when you measure the distance, when you measure from pole, you will measure from right to left, means see the left to right na. So see here, so you are measuring distance from here to here, so you are measuring from here to here, means you are going right to left. So that is the reason here also it will be negative, means it means that whatever the position you will keep the object, the sign convention will remain the same. So that you have to remember, okay. Means whether you take left or right the object, the sign convention according to sign convention, okay, if you apply the u means object distance will be negative only, okay. Now coming to the next time, what is the first point in sign convention is all the distances should be measured from pole, okay. Means just generally if you take a scale, we will start from 0, right. So here we have to start from pole, okay. If you take the object from right side and all, we will take, okay. Even if you take the object on the left side also, if you imagine Cartesian coordinate system also, this p is nothing but the origin, so in that way, okay. But anyhow what we will do, we will follow the right side case, okay, right side object case, okay. Why? Because in your books it is given like that only, so that is the reason Telangana and all state syllabus will follow that only, and even some CBSE books also follow the same, okay. So that is the reason we have to take any one thing and follow, okay. So what I am doing is since books are giving right side, so I am taking mostly right side in order to avoid confusion for students. Okay, in any way if you apply sign convention, the answer you will get the same, even in the formulas also. Now coming to the next, what I am going to say is first rule. What is the first rule? All the distances, means sign convention for mirror you write, and you can take like this, all the distances for sign convention. Okay, for example, for spherical mirror you write for now. Okay, see, spherical mirror, for spherical mirror, right? So what you are doing, all the distances are measured from pole, so this is measured from pole. So this is the first point. And what you have to do, the light rays which are measured, okay, means the distances, all the distances which are measured in the direction of the light ray, okay, so distances measured in the direction of light ray are taken positive. But okay, all distances measured, okay, which are measured in direction of light ray are taken positive, and in opposite direction you have to take negative. So all distances measured, okay, what we will do, first we will take opposite direction only, because generally we will take object first. Okay, opposite direction to the light ray, to the direction of light are taken negative, and the distances taken in the same direction, okay, are taken positive, so this you write. Okay, now coming to the next, the objects, means generally for example object we are keeping on the axis, so the distances measured above the axis are taken positive, means height of the object generally will be taken positive. Okay, so distances, okay, above the axis, okay, above axis are taken positive, and below axis you should take negative. Why? Because here what will happen, if for example if you are getting the image in the inverted position like this, then what you are doing, you are measuring the negative x-axis, it means like that. Okay, so in that negative y-axis, okay, so that is the reason. And one more few more things you have to remember in this. See, mirror formula, you remember mirror formula, what will happen, okay, so you can write like this, 1 by v plus 1 by u is equal to 1 by f is a mirror formula. Here v is what? What is v? V is the image distance, u is the object distance. V is the image distance and u is object distance, for of course from pole. Okay, object distance from pole, and v is image distance, f is focal length. Image distance from pole, of course, f is focal length. Remember, always u will be negative, that you remember. And for concave lens or mirror, for concave f will be negative, f is negative, and for convex f will be positive. Why? Because I'll say the reason. See, generally what is happening is, you are measuring, for example concave lens you are taking, you are measuring the distance from here, from P to F, for example. So you are the light ray actually coming from right to left, but what you are doing, you are measuring the distance from left to right. So that is the reason in concave you have to take the focal length negative, and for convex you have to take positive. Why positive? Because see, for example here you same mirror you keep at the pole or at a Cartesian coordinate system, for example. So if a light ray is coming, for example this is a Cartesian coordinate system like that. If the light ray is coming, it will go like this, okay, but for a person who is seeing from here, for him it will appear as if it is coming from F. So you are measuring the distance from F to P, so it means that the light ray is coming from right to left, R to L, and you are also measuring from P to F, this which is also R to F. So that is the reason you have to measure, you have to take F as positive. Okay, now coming to the next, magnification formula. What is magnification formula? Magnification formula is m is equal to, okay, you can take magnification formula as in the case of a mirror is m is equal to minus v by u is equal to height of image by height of object. Remember, to say about nature of the image, this will be useful. Okay, so these points are useful. Listen with concentration, this is very important. See here, generally if m value is negative, you will get real and inverted image. If m is positive, then you will get a virtual and erect. Okay, so let us go from here. Otherwise, yeah, these points are very important. Okay, if m is, remember, so this is the formula, m is equal to, right? See, as if m is, remember point number 1, if m is negative,